Good evening, everyone. So I am Abhijit, representing Team GENIE, led by Mahi, and we have Afrin, Ronak, and Sarda with us. So just let me start with a quick reality check. 80% of a data scientist's time actually goes into cleaning and preparing the data, leaving just 20% for meaningful analysis. That's like hiring a pilot and asking them to wash the plane instead of flying it. It's a huge problem, basically. So our team Genie builds a platform to flip this ratio. We present the AI-powered data cleaning platform, a system that combines rule-based reliability with the intelligence of large language models. So you can transform messy, unstructured, inconsistent datasets into analysis-ready pipelines in minutes. Why is cleaning so painful? Because datasets aren't just dirty, they are messy in unpredictable ways. One column might have dates in multiple format, another might mix categorical strings like male, am, or one. A JSON log might suddenly change schema after a software update. Or you may discover silent errors like outliers that aren't obvious but skew results. Traditional cleaning relies on hard-coded pandas or SQL script. These scripts break when data changes, don't adapt to new formats, and often have to be rewritten for each project. Our platform automates this entire process with adaptive AI and reusable pipelines. So, what makes our platform different? The first is the use of natural language interface. Instead of coding, you simply say, hey, convert salary to float and normalize currencies. The system interprets, generates codes, and applies it. The next specific or a feature that we have is context aware cleaning. The AI doesn't apply one size fits all fixes. It analyzes data patterns and generates stat trees tuned to your dataset. One more, the one more important is that, for example, say if you have millions of rows in a dataset and gigabytes of and that data set may range a gigabyte or multiple gigabytes. In that scenario, what you can do is that you can just take a stratified sample of the actual data set and pass it through this platform. What it's gonna do is that it will give you a clean data set, but along with that, it also gives you the entire production ready Python pipeline so that you can use that code, snipe it into your actual data, which actually carry this gigabytes of, which actually span gigabytes or multiple gigabytes. So to summarize, after cleaning, the system actually export not just a data set or a clean data set, but a production ready Python pipeline with tests and documentation. You can reuse it across project. It support multi formats including CSVs, Excel with multiple sheets, JSONs, and even text file with NLP preprocessing. In other words, it understands, cleans, validates, and package your data for future use. So let's just walk through a live demo. So before the demo, I just want to explain whatever the things we have here in our window. So first we have configurations. So in the configuration, first we have few models. So we are basically have two options here. One is GPT 4.1 and other is GPT-04 mini. So now GPT 4.1 is a model which kind of handles simpler data sets, kind of a moderate level of data set. But if you have really complex data set in such a scenario, we emphasis to use GPT-04 mini. Then we have two processing mode. One is manual review, another is automatic. In manual review, the system actually asks at every step that is it a right step to move forward for all the strategies and code that it forms. In the automatic thing, it just pass and give you the final pipeline and the auto and the cleaned code. We also track the system is session persistence. The system carries system persistent, so we are tracking the system ID here. And then we have like 5-step process. First is the uploading of the data set. Then we'll detect the schema. We run a EDA, and this EDA report, whatever this system has generated, has been passed as a prompt to the agent, which actually write the correction code. Okay. Once the correction code is generated, you can actually edit, review, put your own inputs, and then we move to the finalization stage. And we have one more button for resetting the session. Now in here, let me just upload a file for demonstration. I'm going to use a CSV. Okay, now this is a CSV. So first we can see that it will prompt the data review. In the data review, we have this indexes. We can find this how my data set is actually looking. So we can review it. We can find number of rows, number of columns, and size of the data set in MBs. In here, we are maintaining the logs. It's a proper logging system and it's tracking the sessions log. And we can actually filter it by level, filter it by action, filter it by like the number of max log we want over this screen. And apart from that, why we are keeping so exhaustive logs? Okay, or we try to cover everything, whatever the process we are doing through logs, because trusting AI is difficult. And nowadays, industry is looking toward what are the ways we ensure that whatever the LLM has done uh, has some backing to it, or it's like we are very sure of it. So for that, we are keeping track. We are keeping track for basically audit trials through logs. Once the we can see the data preview here, we can move to schema detection. The next step in the schema detection, we have a descriptive statistics of the data columns that we have. Okay, in the descriptive statistics, we are keeping track of data types, null counts, null percentage, unique counts, unique percentage, if it is categorical or not, what is the min value, maximum value, median, mode, standard deviation, if it has negatives or not, it has zeros or not, it is like integer or not, and thereafter the categories that we have. Is it a date time? Like basically a comprehensive descriptive statics table that we have here. Thereafter, we can edit the schema manually, or we can just write in natural language what you want to do. For example, if we just want to convert, if you want to do a convert the age column into float 64 for specificity, we just put that only here. Let's just process the final changes. So it will actually goes into the LLM, it understand the query, it understand, it take the schema in context and try to give some code. Just wait for a few seconds. Okay. Once the code generated, it will going to give a strategy summary. It's basically summarization of the code it generated in natural language. Okay, this is the code. You can actually review the code. This is the proposed change. You can approve and apply this code, or you can modify the instruction and regenerate the code, or you can just reject the changes. If you click approve and apply, the changes will be applied, and you can see the data type of age has converted to float from category. Okay, now moving forward, we can apply the current schema and then proceed to data analytics. In the data analysis, it is going to, okay, one more thing that I want to show you in log, that we are also tracking performance metrics. Now, in performance metrics, we have total number of operations, LLM interaction, field operations, if what are the number of successful operations, what are the number of data operations, and such. And here you can find this in the logs, a comprehensive data analysis that this LLM has run in the background. From everything, the bonds, the Z scores, the IQR ranges, the memory uses, and literally everything. in a structured way. So the log for what we have applied as an schema. Okay, now we, as you know, like this has four small windows: the data quality analysis, and first quality metrics, that it represents data quality score. So this data seems to be perfectly, it's 99.9 score. I think data quality score needs a little improvement. The missing value percentage, the duplicate percentage, the outlier percentage, total columns, and memory uses. In the detailed reports, we can find what are the missing values, what are the duplicate entries, what are the outliers, what are the data type analysis, and as such. In the AI insights, it will going to give you a natural language insight or report of the data analysis or the EDA that we have done. Analysis summary, critical issues, what are the recommendation, and a suggested strategy for uh, correcting or cleaning the data or validating it. In the visualization, we actually ask it to generate visualization for us. Let's see. So it's basically going to give us few, or I think 6, 7, or 10 EDA graphs, which is actually strictly based on the schema or the data set that we are pushing to the system, and it is dynamic. The code is again getting generated by the LLM. We have to wait for a couple of seconds. And here you go. We have one missing value heat map, then distribution of numeric columns thereafter, and these all are interactive. And thereafter we have category counts for categorical columns. Okay, now this graph I think needs to be a little improved. Okay, but for now it's good to go. And obviously you can view the visualizations code here, and we can add a few more things in future, for example editing this visualization code or regenerating this visualization code, or we can pass some natural language input to it so that uh, these visualizations can be improved. Now we can proceed to data correction, which is our fourth step or the second last. In the data correction step, it already had all the reports generated earlier in the during the ADA phase or the analysis phase. But if you want to add any additional correction issue, correction instruction, we can add. For example, do it properly. Then we can just click on generate correction code. The correction code is generated. Says basic data cleaning, handling missing values, removing duplicates, and standardizing format. And we can execute the correction, or we can modify the code. Here we got the code. Uh, we can pass our own input, for example. Print. Okay, we can save the image. Okay, we can show accurate. Changes. Okay, as we find, we have this print okay here, and we can move forward to execute correction. It says this is the execution logs. This is the clean data set. Okay, now we have all of those things cleaned. Okay, and we can again further, if we try, we can have this future scope of adding one more step, like post analysis, post cleaning analysis. Post cleaning analysis. Okay, now we can move to or proceed to the finalization. In the finalization, it asked, okay, Click on the generate final pipeline to complete the data cleaning process and enable downloads. And at any moment, we can download things from here as well, like at any step. For example, just after schema cleaning, if we want that we need to download the clean dataset, we can. And after the finalization step, this download pipeline script will be enabled here. We can again at any step download the log files. We can download at any step download this Excel report and the text report. So these are basically progressive. Like as we move through each step, things are going to add in this text report or Excel report, log files, and the dataset. Obviously, logs are again extensively maintained. Here you go. This is the generated data line, pipeline length. It's 9,016 lines of code that has been there in the pipeline code. The final clean data set, the cleaning summary, and we can download the CSV. We can download the pipeline here, and we can download the session logs as well. Okay, we can download the Excel report and we can download the text report. I will go through this report once and we can again start a new session. So before viewing the outputs, what we are getting kind of like reports and the pipelines, I just want to make you go through with the go through the code structure, basically a high level overview. So just let me go to the GitHub report. In the GitHub report, okay, these are basic descriptions you can read about the app access and all these instructions. Now, a high-level architecture overview is like that. We have a Streamlit web app as user interface or UI. In the core engine, core processing pipeline, once the file get uploaded, it is ingested, and we are again logging and monitors everything through logger. We are maintaining the session extensively, and we are storing the data storage for now temporary, but we can again integrate databases or file systems as we need, and we are also maintaining this log files as within the data storage as temporary storage. Okay. Once the ingestion is done, it goes to schema detection and management. Then it's moved to, and there are these LLM services enabled over these 4 steps: data analysis and quality checks, data correction and cleaning, and pipeline generation. Okay, this is the basically a detailed component architecture. The file system moves like that. We have this main module, which is app.py, which has the purpose of Streamlit application and UI orchestration. We have written these key functionalities you can again read about. The file handler, which handling the multi-format file ingestion processing. Schema manager basically detects schema, validate it, and type optimization. Thereafter, data analyzer complete data quality analysis and profiling, basically the ATA part. Data corrector or AI-powered cleaning code generations and executions has been done here. A text processor, we have one separate text processor, which is specialized for text data cleaning and NLP operations. Pipeline generator for reusable pipeline script generation, and LLM client for OpenAI integrations and all those prompt management. Session manager for session state persistence and recovery, and logger.py for logging system or audit trail, and configuration, which is the centralized configuration management, like API settings, resource and limit, model configurations, prompt templates, etc., etc., etc. Technologies that we have used for frontend, obviously Streamlit, programming languages Python, data processing using pandas and NumPy, statistical analysis using SciPy, visualizations using Plotly, Matplotlib, and CBOT. AI/ML stacks for LLM provider, we have used OpenAI API. NLP using NLTK 3.8 plus. Okay, text processing for using regular expression and pattern matching. File format support, spreadsheet from OpenPy Excel. Data format CSV, Excel, JSON, text, etc. Pickle and JSON for serialization. And we have also used, I think, HTML. Thereafter, for development tools, we have Python env, HTTP client, and code analysis using ST. File system here, you can, this is basically overall file system that we have. For local setup, the instructions has been given. Configurations is like the size file size default limit is 1 minute, which we later extended to 200 MB. quality thresholds, and model preference prompts, such as these are the core capabilities. Basically, it's a AI-powered code generation platform, multi-format support, intelligent schema detection, natural language interface, comprehensive analysis, reusable pipelines, advanced features such as session persistence, complete audit trials, processing models, smart fallbacks, code validations, package generation, quality assurance using. Okay, now one more thing is that we are using retry logics or reactive frameworks where if the LLM failed to generate the correct code, it will get analyzed itself and the error will be fed back to the LLM so that the correct code will be generated. The sandbox execution is there, performance monitoring is there, error recovery using automatic retry with exponential backoff for API calls. These are some best practices. These are some troubleshooting tips and some real world examples. What's new we are doing. That's all we have here. Now let's move toward the outputs that we have downloaded. Let's start with just 1 minute. Let me share my entire screen. Okay, here you go. This is the final output that we are downloading. We have the original data, we have the schema, we have the quality report, and some. These are the few basic summaries or the Excel report. Thereafter, there thereafter we have the text files. Text report, we have data cleaning report and quality matrices and logs, sessions, and a detailed report basically. Okay, now the data pipeline. Okay, and here you got the data pipeline. Okay. And similarly, the log JSON log is as similar kind of what you have seen in the text report. So that's basically the output path. Let me come to some closing comments. Okay, so here we have the interface again. Okay, so here's how it plays out in the real world if we just want to look at what impact it will made in real world. Imagine a retail analyst with a sales data set with 20% of rows are missing in transaction date, mixed currencies in INR, USD, UAR, and duplicates due to system glitches. So this platform will detect all three problems in schema analysis, suggest appropriate fixes, and generate validate Python code, and then execute it safely, and output both the clean dataset and reusable script. Instead of writing hours of Python code, pandas code or Python codes, the analyst fix everything in just 10 minutes. I also want to look forward for whatever our future outlook is. I also mean I already have mentioned few of them during the uh, demo presentation. So we can actually provide a domain-specific cleaning template for healthcare, finance, and scientific data. We can add collaborative features for team-based cleaning. We can add multilingual supports, and it's also at some extent support multilingualism. And hence, like what I can say is this AI-powered data cleaning platform isn't just a tool. It is a co-pilot for data scientists, bridging the gap between raw, messy data and clean, analysis ready insight. It saves hours of manual coding, improves reproducibility, and empowers even non programmers to take control of data quality. So, at the end, thank you, and I am happy to build this platform to industry grade scale. Since this is just a prototype, thank you for listening.